Who knows what evil lurks in the GPUs of Teslas? The shadow mode knows, or does it? Plus, Elon Musk weighs in on when artificial general intelligence will arrive for all of us. Let's take a look. Before we dive into today's video, I want to introduce you to an awesome AI tool for productivity, Magical, who is kindly sponsoring today's video. Magical is a free AI-powered productivity extension that has completely changed how I manage my time. Let me show you how it works. One of my biggest time-consuming tasks is writing emails for both my YouTube channel and my startup, Artomatic. It seems like there's a never-ending stream of admin work that needs to be done. This is where Magical comes in. With Magical's templates feature, I can create shortcuts for frequently used text, saving me hours each week. Whether it's responding to emails, answering direct messages on X or LinkedIn, or working up scripts for my videos, Magical's templates make it all so quick and easy. Magical also helps me keep up with new contacts and track details of people for future reference. It's easy to update your CRM in one click with Magical, whether it's for personal use or for work. This is great if you need to get information from multiple web pages, and Magical pastes it all into a spreadsheet. Instead of copying everything manually, Magical can do it all for you, making data entry an absolute breeze since it's powered by AI. Magical can, of course, do a lot more, like AI Reply, which replies contextually to entire emails for you in a second. The main thing about Magical is it's designed to save you time. So if you're looking to boost your productivity and automate your workflow with AI, I highly recommend checking out Magical. It's free and it'll save you hours of work each week. Be sure to check the link in the description below to try out Magical for yourself. Get Magical for free and save 7 hours a week of busy and boring work. Thanks again to Magical for sponsoring today's video, and now let's get to it. Hey y'all, it's Dr. Know-It-All. I'm going to start with about a 1-minute clip. I think it's 1 minute and 20 seconds of Elon Musk talking in a recent interview. It's not the greatest quality in the world, but it's Starlink and he's on his plane, so it's actually pretty cool that it works at all. Anyway, it's when he thinks that AGI, or artificial general intelligence, will arrive, and what the definition is and why he predicts that it's going to happen about 50th percentile within the next few years.
When things are changing rapidly, the ability to predict the future, I think, becomes a lot harder because of the rate of change is so great. But I think some things are fairly obvious to predict, which is that we'll have AI or AGI that's at a level that it can really do almost any cognitive, I think really not almost, really any cognitive task. It's just a question of when. One could debate, is it, smarter than any human at the end of next year, or is it 2 years or 3 years? But it's not more than 5 years, that's for sure. Not like it will definitely happen, but if you say if you ask me like what's the 50th percentile, where it's like your kind of over under is kind of even, that's where I think it's probably end of next year before AI can do better than any individual human could do. But it's a much higher bar to say, well, is it smarter than human intelligence collectively? But if the rate of change continues, that's why I think probably 2029 or maybe 2030 is where digital intelligence will probably exceed all human intelligence combined. And there, I think it's always helpful to look at these like fundamental ratios. If you look at the ratio of digital to biological compute, if you sum up the higher level cognitive capacity of humans and think of that as compute, and then compare that to what is the digital compute, and the rate at which this is growing is just boggles the mind. But that's why I think it's, I think 2029 or 2030 or thereabouts, that's I think a reasonable time frame for where you'd expect the cumulative digital compute to probably exceed the cumulative biological compute of higher level brain functions.
So yeah, there's a lot to unpack there. First of all, he says that he believes the over-under, in other words, 50-50 odds, that AGI will be smarter than any individual human. So that would be like your Albert Einstein of the world or something like that. So right now, you might argue it's about as smart as a cat, maybe as smart as a chimpanzee, something along those lines. He's saying he believes by the end of next year, so somewhere, call it 18 months to be generous here, by the end of 2025, his prediction is we've got a 50-50 chance that the smartest of these large language models, or whatever takes the large language models' place, but the smartest of these AI models that are going to be built right now and into the future in the next 18 months or so, that one will be smarter than the Albert Einstein of the generation. I don't know who that is exactly right now. Maybe it's Elon. I don't know. A lot of people would argue he's not that smart. I think he's actually a very intelligent guy. But, take your really, really intelligent theoretical physicist or whoever that is. And this collective entity, because remember, these things are not running inside of bodies. They're running inside of giant data centers. So it's not exactly a one-to-one comparison. It's not like, and certainly per watt, these things are incredibly inefficient right now, right? It takes massive megawatts for these things to run, whereas we humans run on just a couple of watts of power. So we're actually very energy efficient. So in terms of compute per watt, humans are going to be ahead for a long time. But in terms of raw capability, his projection is 50-50 by the end of next year that we'll be looking at an AGI that is smarter than any individual human. Then he says, if we continue to look at the same rate of progress for the next 5 years, he says, 2029, 2030 is when we should be getting an AGI that's smarter than all of humanity collectively. And his basic contention here, and he talks about this, he says we're getting, in other places, he said we're getting 10x compute increase every 6 months or so. If you haven't seen my discussion with Scott Walter, you can check it out up here if you're interested. But anyway, he's observing that we're getting about a 10x compute increase every 6 months. So we're getting this massive amount of compute power increase digitally every 6 months, every year or whatever, like order of magnitude more every 6 months. That's a crazy amount. And human beings, the only way that we can sort of collectively grow our intelligence is to have more babies. And right now we're not doing a real good job of that. But anyway, we got like 8 billion of us. And let's say we go crazy and have lots of babies. By 2030 or whatever, we're still going to be looking at 8 billion, right? It's not going to be that much more because people die, people are born, things like that. So we can grow a little bit, but we're not going to grow a lot. Whereas silicon is going like ka-chunk, 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 like that, right? So it's a pretty obvious thing that if the trend continues, and he does say that, he says if the trend continues the way it is, and there's no real reason to think that it won't at this point because humans are incredibly clever about eking out more and more and more out of our hardware, and then also doing a better job with our software and the architectures and everything so that they run more efficiently on the hardware we have. But regardless, we're looking at a situation where silicon compute is increasing by an order of magnitude in less than a year, whereas biological compute in the form of human beings is increasing by teensy little amounts, right, all the time. So relatively speaking, we're not collectively becoming all that much smarter, whereas computers are becoming way smarter than they were. If you look back at 5 years ago, 20 years ago, they're just primitive at this point, right? If you look back 20 years ago and think about what the state-of-the-art GPU was at that point or something, it's just kind of ridiculous, or CPU as well. So you're looking at just incredible increases in the amount of compute capacity that is available. So again, he does hedge his bets a little bit because he's like, if the rate of increase continues as it has, but it seems pretty reasonable that that's going to happen over the near term, right? The next 3 to 5 years or something along those lines. If that continues to happen, it seems pretty reasonable what he's saying, that in 5 to 6 years max, we're going to be looking at an AGI that is smarter than all humanity collectively. That's a pretty scary thought, but it's also pretty amazing because what does that mean? We have effectively an oracle at that point that we can go to and say, oh, great AGI, we have no idea how to deal with climate change, or we have no idea how to deal with waste issues, or we have no idea X, Y, Z. And this thing will be smarter than all of us together, and hopefully we'll be able to come up with really good solutions that don't involve killing all humans. That would be a bad thing. But hopefully this entity, and I prefer many entities, I hope it's not just one oracle, but I hope it's like a million of these things that will all be smarter than collective humanity. That would be incredible. But anyway, that if we can get a whole bunch of these things that are able to think about these problems and are hopefully aligned with the best interests of humanity as well as itself, that we will be looking at a situation where we could be getting to an age of hyperabundance very rapidly. And that would be really cool. But in the more near term, in the next 18 months or so, if Elon is right, we should be looking at getting to an individual entity, something, whether it's ChatGPT or Claude or something else, Llama version 12 or whatever, just some sort of entity should come online that should be smarter than any individual human. In other words, whatever benchmark you want to throw at it, it will do better than the best human being. And that will be a pretty remarkable milestone when that happens. And at that point, don't forget that AGI, whatever that thing is, will be able to help us build the next generation of it. In fact, these things already do that. They increase the productivity of chip designers. Anastasia in Tech, she talks about this, that chip design these days requires a form of AI to be able to do this because humans are just not smart enough anymore to figure out how to path all of the tiny little, billions of these transistors and capacitors and resistors and all of that stuff that make up chips these days. We can't do it anymore. And so therefore we depend on AI to do this already. So in a way, they're already helping to create their own babies. And so if we turn from the largest scale, gigantic data centers that are, hundreds of millions of dollars to build, potentially eventually billions of dollars to build, if we turn from that to edge computing, in other words, like your automobile, like your Tesla, or eventually humanoid bots like the Figure Bot or Optimus or Aptronic or whatever, if we turn from those things, we're going from these gigantic systems that could become very intelligent, but will be incredibly power hungry, down to much smaller edge computing devices, which, eventually your phone or something, although who the hell knows what Apple is doing anymore. I don't think they're doing much of anything. But if we look at these edge computers, we're looking at a situation where you're going to have to take these big models and you're going to have to quantize them and distill them down into something that runs on a much more efficient manner, both in terms of memory, in terms of compute power, and also, of course, in terms of just pure wattage, because most of these things run on batteries, not on electricity out of the wall. So they're very highly dependent on the amount of power they draw, the amount of memory, and the amount of compute that they have available. But we're seeing a lot of models, including several versions of Llama, the open source thing that Meta has released, that have been quantized and distilled down into being able to work on a laptop and even potentially on your phone at this point. And when we get to this edge computing, one of the things about edge computing is that it doesn't do any training. It actually is just an inference engine. It just predicts things. The training actually goes on in the big giant data centers. But what you can do with these edge computing devices, like humanoid bots and especially cars these days, which we drive around, we collect data. And we're collecting a ton of data that Tesla actually needs to train their vehicles. And for a long time, one of the big tricks that Tesla had was that they used what's called shadow mode in their vehicles to train the cars to be able to drive better. So what is shadow mode? Shadow mode was running the software, Full Self-Driving 10, Full Self-Driving 11, in the background. It would make predictions and then it would look what the human being did. So let's say I'm driving and the computer predicted I should turn the steering wheel 2 degrees to the right to go this direction for some reason, and I actually turned it 2 degrees to the left, to counterclockwise. And the car would go then, oh, that's a mismatch, right? It's my prediction is significantly off from what the human did. I will flag that and I will send that data back to Tesla's mothership so that they can put it into their data set to do some training on. That was called shadow mode because the car was driving. It wasn't actually doing anything, but it was making predictions. And then those predictions were measured against what a human was doing to figure out how well the car was doing. And any mismatch was considered an error and sent back to Tesla for analysis and eventually placing into the data set to help train the vehicle to do a better job. But here's the interesting thing. I haven't heard much about shadow mode at all recently. So I kind of went back and just, did a quick Google search and stuff like that. So I found this article from December of 2019, so about 4.5 years ago, a theory on how shadow mode works or will work. So that was like back at the beginning when we were first thinking about that. I also looked at this. Tesla's autopilot depends on a deluge of data, but can a fire hose approach solve full self-driving's biggest problems? This is August of 2022, so not quite 2 years ago. And then another one from just about 2 years ago, Tesla's Full Self-Driving V11 in shadow mode and why this matters. Tesla Full Self-Driving V11 is running in shadow mode on Tesla vehicles. This version will combine autopilot and auto steer on city streets, the one stack to rule them all. We've heard that. It's been around for quite a while, hasn't it? And then in a really weird twist of meta stuff, let's go over why this is significant from Dr. Know-It-All. That was really weird. I was not looking for myself in this. So it's very strange how all of this stuff kind of rolls in. And it's hard to believe that we're already looking at it 2 years ago. It's crazy that this kind of thing takes so long to actually happen. But anyway, we've seen a lot of stuff about it from 2019 to 2022. We saw a lot of stuff, but then things really go silent about it. And so I asked Grok to find me any posts in the past 12 months. And I said, find me posts in the past 12 months that are from Tesla employees discussing Tesla Full Self-Driving in shadow mode. If so, please give me the link to them. And it replied, it looks like there are no public posts from Tesla employees discussing Tesla FSD shadow mode in the past 12 months. However, I can provide you with some general information on the topic. So of course, Grok is not a 100% trusted source, but I Googled it, couldn't find anything in the past 12 months. I went and asked Grok to look for me for the past 12 months. I can't personally remember anything in the last 12 months. Scott Walter, I asked about it the other day, and he couldn't remember anything in the past 12 months. So maybe there's stuff out there, but I have not been able to find it. It seems like everyone has gone dark on shadow mode. Get it? Shadow dark. But anyway, it's definitely not as in the forefront and not as discussed from Tesla as it used to be. So what are the reasons this could be? I think the number one reason is that Tesla used to have, they have their hardware 3 and hardware 4 has 2 redundant systems. Basically, it has a board, but it has basically 2 completely redundant systems. And they used to run full self-driving on one, and then they had a backup. It was a redundant system that ran the same thing in case something went wrong. It could switch over between the two of them. Several years ago, I remember Andre Karpathy talking about this, but probably around 2022 was when they kind of expanded it. Full self-driving eventually took over both of these things, used all of the memory, used all of the GPUs, used all of the CPUs, all of that kind of stuff. And then with hardware 4, I'm not as clear about that because they don't really talk about that stuff, but there are reasonable odds that it's probably using all of hardware 4 as well. So we're probably looking at a situation where there's not as much room for this thing to actually be operating in shadow mode as there used to be, because you don't have a redundant chip that's operating in the background. However, the counter argument to this could be that it's running in shadow mode, right? It's going and it's operating, and then when you press the stalk down or push the button or whatever, it goes into active full self-driving 11 or 12, and it just flip-flops back and forth between shadow mode and actually being active. That is quite possible, and it could be happening, and it could be flagging the things in the meantime. So that brings me to the second and what I think is the real reason why it's not running shadow mode anymore, and that is that the vehicle is pretty darn close to what humans are doing at this point. So in other words, the vehicle used to diverge pretty significantly from the way human beings drove, and so you could utilize that to flag things and to train against it and say, like, the human was right, what did I do wrong? The problem now is that full self-driving 11 and especially full self-driving 12 is really, really good. So there's not nearly as much divergence between humans and full self-driving anymore, and there is an argument to be made that in many cases full self-driving 12 is actually doing a better job than the human when the human and full self-driving diverge from each other. In other words, if you're not the greatest driver in the world, or even if you are, but you're in a rush and you just kind of like go and do something like, run a yellow light or something like that, that you're actually doing something that is worse than what the full self-driving would have done if it had remained in control. So it means that shadow mode is not nearly as useful anymore, because if you're not getting significant divergence between a human and what the computer is predicting, and then more importantly, you don't know that the human is the ground truth, like the human might actually be wrong in this case, then you're looking at a situation where shadow mode is not particularly useful anymore. So at that point, what becomes more important is just curating good data. In other words, things that are obvious edge cases where a person intervenes and it was obvious that there was a safety critical intervention or something along those lines. And this is the kind of thing where Tesla can build in this data curation flywheel, where it could be looking for specific things. And it could be looking for, say, violent disengagements, or it could be looking for the brakes being slammed on immediately after, full self-driving gets disengaged, whatever. So it can look for flags and it can pull those in and use that to do training. But in general, shadow mode is probably not that useful anymore, because 99+% of the time, the two things mesh really well. And even in the 1% where they don't mesh, there's a really good odds that full self-driving was actually making the better decision than a human is. And of course, this begs the question, what happens when we transfer from a car to Optimus, the Teslabot? The number one thing is that we're going from a dual, like, redundant hardware 4 system to a single one. It's like half the size of the board. So we don't have the redundancy that was there anymore, which means that shadow mode is not as useful. But number two, the robot itself has to actually operate all the time. Like, the car can have a driver in it. You could argue that Optimus could have a teleoperator who is doing things with it, but even when the teleoperator is operating the bot, it's still got to stand up. Like, the car just automatically, it's sitting on 4 wheels, so it's never going anywhere, right? It doesn't actually have to do anything, but the robot, even if a person is teleoperating the arms or something, still has to balance itself and not fall over. So it's CPUs, GPUs are being utilized constantly to actually be in action. So shadow mode in this case, again, is not particularly useful. It could be in a mode where there's a teleoperator who's like, controlling maybe the arms or the head or part of the body or something, but that's not shadow mode. That's actually a different mode that it would be worked in. And so shadow mode would not be particularly useful, or really actually very easy to do in a humanoid robot as opposed to a vehicle. So we're looking at a situation now where I think that the days of shadow mode have kind of disappeared. I don't think it's necessary anymore. And the really interesting part here is this is coincident with Elon Musk talking about how full self-driving is a form of baby AGI, at the same time that he's saying within the next year and a half or so, we're going to get to an AGI that's actually smarter than any human being. Then we're going to have these edge computing devices that are kind of baby AGIs, not necessarily smarter than any human, but very, very capable and very, very smart. So if you think about the full self-driving capable cars that are already on the road, we're looking at around around 5 million of those things, and then any humanoid bots that come online as well. We're looking at millions of these very capable, reasonably intelligent entities, and then you attach that to super, very intelligent entities that are running out of data centers, and you start to look at a world that's going to be very different than it is even today. Like by the end of 2025, which doesn't seem that far away at this point, we could be looking at a situation where we have incredibly intelligent data center entities, and then we have humanoid bots and cars that are scurrying around all the time, talking to us through things like Grok or ChatGPT and taking care of tasks, but being very, very intelligent in specific domains. So we have an AGI in a data center and a more specific type of AI that's really smart at what it does, that's embodied and using edge computing and is functioning at a very, very high level for whatever specific tasks it needs to do. And so that means in less than 2 years, we could be looking at a world that is incredibly different than the world today. So that's what I've got. What do you think about that? Do you think that Tesla is still using shadow mode and they're just not talking about it anymore? What do you think about the odds of AGI happening by the end of 2025 and then artificial superintelligence by the end of like 2029, 2030? Let me know in the comments. And in the meantime, thanks again so much to Magical for sponsoring today's video. Be sure to check my link in the description and start saving 7+ hours a week. In the meantime, I'll see you in the next one. Bye-bye.